So, uh, so as always, now everybody see annoying message that meeting will be recorded. So let me introduce today Rodrigo Simon Bavaresco from University Unicinas from Brazil, who will tell us about the context-aware modeling for psychology today. So you're already sharing your screen. I think I can just mute myself and maybe I'll switch off the video for you while you're presenting. So to save the bandwidth, so please take a stage and guide us through this interesting topic. So welcome.
Yeah, thank you very much, Professor Ivan. Thank you for the introduction. And once again, thank you for the organization of the Open Days and related research and development project. Okay, let's get started by providing you some specific introduction about myself. As Ivan said, I'm born and raised in southern of Brazil. I did my bachelor's degree in computer science at the Unicinos University, as well as my master degree in applied computing. So I've been working as a software engineer since 2011 until now, and from 2019 to the present, I'm research assistant at the innovation portal of the Unicinos University. My research and development interest encompass ubiquitous and mobile computing and the Internet of Things. They are very related topics, and of course the application of the context awareness on these topics, along with artificial intelligence. My main focus of research I've been working is on the healthcare and humans' well-being. So I'm very interested to these applied stuffs of computing. And on the right side, we have some links to my contact, to my OrcID profile, as well as LinkedIn. Feel free to contact me anytime. You are always welcome. So for today, I'm going to cover an interdisciplinary approach that comprises a group of psychological, biological, and computing topics. These topics together provide the whole idea of this presentation, and at the end of this presentation I will show some possible modeling aspect and some software artifacts that can shape a software solution. So I believe this presentation will take 30, maybe 40 minutes. So let me introduce 4 major topics that will cover the presentation. So I will start presenting and talking about some background concept that comprise psychological, physiological aspect, and how we interchange these aspects to name the psychophysiological topic, and of course the context awareness that is very related to the ubiquitous computing to help shape the modeling and to help structure the whole things around psychophysiology. So for this, I will cover so the modeling aspect, and after that, some implementation concern and some implementation description of a use case I worked, and some challenges I judge it will be helpful for future research or opportunities and this kind of stuff. Uh, first, some initial concept around the psychological aspect that is very tied up with my motivation behind this topic and this idea to work with uh, applied computing. So in 2017, the World Health Organization presented us with a not very good statistic about how the world is suffering uh, with mental health, more specifically with anxiety and depression. So more than 300 million people suffer from depressive disorder, and more than 200 million uh, suffer from anxiety. And of course, the last 2 years, according to the situation we faced in the world from the COVID-19, this aggravated the situation as well. And we have very recent and very good references and academic references that explain these stuffs, that the pandemic may decrease mental health, and we need to help people in this aspect, and also to help professionals from the psychological science with computing stuff that we can create, considering that technology is advanced more and more. So we also know that stress, the mental stress, the working stress, stress at university and daily stress may reduce daily performance of the individual, and during the time this may cause cognitive dysfunctional and also lead to depression and anxiety. So we have a cycle here, that is stress leads to the anxiety, and if we have chronic anxiety during a very during a long period, the individual can suffer with depression as well, and this is, of course, this is not good for the individual and for the family of the individual, and also for the society itself. So we need to treat to present treatment for these individuals that suffer this kind of issues. So psychotherapy is one of the most accepted, and it has presented very good outcomes to deal with mental health issues and to help the individual to cope with mental health issue. But the traditional method of this traditional method of assessment is a little subjective. I mean, with this, psychological problems itself can make difficult to understand the whole scenario, because the individual will have difficulties to explain their feelings, and memory problems also will provide some issues to identify how is the daily situations of the individual, and of course the ability to articulate the symptoms, because the individual will need to speak, to talk about these issues and the daily routine, and the mental health, even it is originated in the brain, three main factors implicate for the mental health condition of the individual that will lead to the anxiety and depression. These three main factors are the biological factors, that it comprises genetics and an hierarchical aspect from the parents, the psychological factor itself, and also the social and behavioral aspect. These three in combination can lead to mental issues if the individual will not cope with these properly. So the psychophysiology is a topic that combines and that is interested in the exchange of the psychological, social, and behavioral phenomena with physiological arousal and triggering. This combination leads to the psychophysiological topic. But why? That's because the human physiological condition can be described by the autonomic nervous system, that is a branch of the nervous system itself. The autonomic nervous system is responsible for involuntary reflexes of the body, and it is divided into parasympathetic nervous system and sympathetic nervous system. And the parasympathetic division is responsible for some reflexes on the body, such as constrict pupil, constrict bronchs, slows heart rate, stimulates stomach. On the other hand, the sympathetic subdivision is responsible to dilate pupil, to dilate bronchioles to receive more oxygen, and also to accelerate heart rate, to put blood into our muscles, and to help the body in light of situations that are bad for our body and for our health. For example, if the individual is on the sea and a shark appears, the individual will need to run away from that shark. And for this, the sympathetic nervous system will be activated, and this condition is known as fight or flight. But the problem is when the individual have this sympathetic trigger, but the individual itself is not on a very hazardous situation. For example, during daily routine or during daily job, and with chronic sympathetic activation, we can lead to the stress and of course to the anxiety, because the physiology is being triggered, but our mental health as well, our mental condition, our psychological condition as well, because the individual understand that the individual is aware that that situation is a bad situation and may cause some damage or some hazard. but not every situation provides this. The individual will have to understand and to understand what is a real hazard situation. For example, daily normal situation normally, of course, are not so hazard than it should be. So more specifically, talking about the physiological aspect, I've been working with heart rate frequency and heart rate variability that are there are two factors derived, of course, from the heart rate beat. So this is a very researched aspect regarding physiological arousal, and academic has been working with and providing very good stuffs on how heart rate frequency and heart rate variability reflects the physiological triggering, and the idea behind this is how we can use these measurement and apply some kind of machine learning to try to derive and infer some psychological aspect. That's because I'm talking about the physiological one right now. So the heart rate, it comprises the PQRS and T waves, and the electrocardiogram illustrates these waves, as you can see on the left side. And the idea behind the heart rate variability that is presented on the right side is to try to identify how our interval, that is, how the difference between two sequential heartbeats took longer. So this is measurement. This is measured in milliseconds, and the picture in the figure in the right side shows this interval during the time, and we need to consider during the time. That is because we have a basis of a time series, because the heart rate is considered during the time. And okay, let me move forward of how we fit context and context awareness and some computing artifacts into these previously mentioned aspect. So the context is the state of entities during the time. The definition of the context is this. And entities, we can model a lot of different entities to comprise the context. For example, the user identification, the time of the user, the location, and the time that the user is the time that user spent or in some location in daily routine. But the user ID is not just a numerical identification, but more than this. When we talk about user identification, we need to take into account the user habits, the user profile, maybe on web, maybe profile on healthy aspect, on maybe the profile on the specific work of the user. And of course, the physiology also comprise these entities, and the user's psychological state as well. So according to what I've said in the previous slide, considering that the heart rate variability occurs during the time, when we have a group of entities computed and recorded, retrieved from individuals' daily routine, and this recording is done having heart rate variability with main aspect to create that context, we have then a context time series. So that group of information comprise a context time series. And thinking in a broad situation or a broad computing solution, for example, we can save this context time series and persist this for a long time. So we call this as a context history, and disregard to the entire history of that user specific. And of course, we can have for multiple user itself on the database, on the persistent. And this is a relevant ubiquitous computing feature. But how we get this information of entities? Nowadays, with the advances of the technology, we know that almost every people, and I would say every young people has a smartphone, a smartwatch, maybe a smartwatch, and even some wearable and some other artifact, maybe a chest belt and so on. So these devices can be used to retrieve a lot of information from the user. And this can be information from health, from, of course, the profile, from the daily situation, daily routine, working aspect, and so on. And this is important because these devices provide a daily monitoring, primarily considering social and personal environments. And this is better than laboratory monitoring, because when we enter in the real scenario of the user, the real life, of course, this is very hard to do software for this, but it's not so easy. But we have a very good and very, how can I say, maybe accurate measurements from the daily routine and what is happening with the user during daily situation. But not just these devices itself. We can have the whole spectrum of the Internet of Things applied to retrieve measurements from the user. Maybe on maybe at work in the industry, maybe at I don't know, leisure time, maybe during the gym, or in the parents' house, market, maybe on bank. I don't know. Opportunities are here to explore how we can derive profile aspect from the user. And the Internet of Things, of course, this contributes to this kind of data retrieval. But why context awareness behind this data retrieval? That's because the context awareness benefits psychophysiological scope, primarily improving computing performance regarding the features we have from the user. We can better organize this feature, and we can have one formal structure to manage situations, information, and data from the daily life. And with this, we can correlate, for example, physiological with any other contextual information, And why? The answer is, to my mind, this should be done to create insight to improve psychotherapy. This is what I believe. I like to create software solution, not to replace professionals, but to help them with technological aspect and all that technological advances we have had during the last 10 years, maybe. So how we turn this into software modeling? That is a very relevant question, and this is the main scope of how we can characterize this information and group this information into software modeling. So I will use an already published article, but not the article itself and not the result of the article. I will use just the idea of the modeling presented in that article to help explain for you how we can model these entire artifact. And feel free to read the QR code on the right side of the screen, and to go into the Elsevier's website, and feel free to download and read the paper to follow some aspect that this presentation is based on. So we need to model the knowledge itself, that is the user situation, the user's physiological aspect, psychological, and all these stuffs I previously mentioned. We need to organize this concept into an structure that we can call this as context, and of course one structure that is machine readable. And this structure, we can use one of these structure. Of course, we have many other possibilities of modeling, but for this case, I used an ontology. Ontology provides a way to describe a domain and provide indexing on these semantical information, as well as reasoning. That is the main capability of the ontology, to derive novel information, novel knowledge from the knowledge already existing. That is, from that daily situation we measured in, using those mobile devices and other IoT stuffs. So the goal of the ontology is to model the context, and I will show you one possibility of how we can model these stuffs. And so in this figure depicts the context itself. What I mean, the context. So in the middle of the image we have an entity. This entity is named as context, and it is related with any other entities using two types of relationships. We have the first relationship that is related to, and the second one is subclass of. So the context is comprised of a date time, the identity, a low-level context, and a high-level context. The low-level context is information that is combined with date, time, and identity, but is more specifically to raw information, and it is more near to raw information we read on the devices. For example, the activity that can be running still in vehicle or walking, and this activity is derived from GPS, accelerometer, gyroscope, and so on. Of course, the ontology shows some major concept and some abstract concept. This is because we do not have the GPS class here. We do not have the gyroscope and so on. But if we specialize this class a little more, we can reach out these classes as well. And what's more, for the low-level context, we have the physiology, that this class describe what I've said about the heart rate variability, and of course we have a lot of other physiological features such as electrodermal activity, electromyogram activity, and also electroencephalogram. That's because the physiology class exists here, because we can inherit this class with another class, another concept that we judge that is relevant to the solution we are building at this moment. On the other hand, and more specifically on the right side of this picture, we have the high-level context. The high-level context derived from the low-level one, and we have, for example, the semantic location for the user, the psychological state, some kind of displacement between one and another location, the permanence that the user spent on some location. So high-level context will increase the abstract way we can look to our solution and to our concept, so that are more high-level concept. And these concepts together comprise the definition of the context for psychophysiology. So we have on the one side physiology, on the other the psychological state, and also some entities that combined to bring the profile information and other stuff. So how we can process this information? Because the ontology shows some kind of data organization that is related to our business case, to the entities, to the concept that the application will deal with, will process, will derive, will infer using machine learning. So here we mapped all these stuffs, and now we can work on this, of course, using an ontology language, or using some object-oriented modeling. So for this, we need some kind of services and components to process this information. So we have on the left side the physiological sensor that describe the ECG, and it is connected with the smartphone or maybe a smartwatch that act as a gateway to send information to the cloud. And this architecture combines some components with an agent-based modeling. So I will talk later about the agent stuff, but we have here four main components that are named as service, identity, data, and query. And they are responsible for one major thing in the application. More specifically, the data component will retrieve and persist the time series on the context persistent to create the context history. So we have, in addition to the components, we have the four main agents. We have an agent that is coded and modeled on the smartphone, and we have an agent, three agents that was created on the server side. And why agents? Because agents are autonomous pieces of software that runs into an environment. So if we look to the left side of this picture, we will see an agent running on the smartphone. So the environment of this agent is the smartphone and all these capabilities that the smartphone provide. Maybe communication with another application, or reading some kind of sensors, or connecting to the cloud, sending, receiving, managing all kind of information into the smartphone. So agents communicate with each other using messages that can be synchronous or asynchronous messages. And these agents together, they will process and organize information to achieve a major goal on our situation. So the agent is autonomous to make decisions according to the change in the environment, that is the data that is on the input or on the output of that agent, or maybe reading some kind of network stuff. And we can use Prometheus methodology to create this agent. So here we have the agent combination that considers perceptions, actions, and messages between each other agent. And we have, for example, in the left side, four main perceptions, that is four main possible triggers to this agent. So this agent will need to monitor, for example, changes in the location, activities recognized, physiological changes, and date time as well. And considering these changes, and of course with a predefined functionality and capability, the agent will act on some kind of data. And in this case, this agent can communicate with a server-side agent that is represented by the air context agent, sending the low-level context message. This message is, for example, a post of an HTTP post to a server side. This message characterized, and once this agent receives this batch of context, of low-level context, this agent will also need to do some processing aspect that is represented to map tab series to a formal model, create high-level context, pre-process context, and so on. This agent can communicate with our disordered agent. This agent is responsible to the machine learning aspect. So we have here computation of a previously training model using, of course, features. I'll talk further. and to derive the psychological aspect, and also to communicate with our behavior agent to derive some kind of insight to help the psychotherapist and the end of the life cycle of that solution. So we have here in this picture the specification of the capabilities in the left side of the air context agent. For example, once we have a variable context that is characterized by low-level context, we can identify this context and save this to the history. And once this agent receives a new query or another perception, we may code, the agent will be responsible to group this context, filter this context, remove noise, maybe on the low level, maybe on the high level, formalize these time series, and send to, for example, to the art disorder agent. Once we have the formalized time series, maybe a low level or high level, we can then apply the a normal machine learning pipeline, I would say. So we can pre-process these clean artifact, extract features, select those features, run inference on previously training model, and so on. How about the implementation? So a possible implementation of this solution I've talked about is represented by the mobile application created using the Xamarin framework and coded using C# with an SQLite relational database. And for the wearable to read the heart rate beat, we have the Polar Age 7 that is connected with connected through Bluetooth Low Energy with the smartphone. So the smartphone application read these continuously, derive the heart rate measurement, and group and create that context in that specific moment, and will aggregate in context and of course saving these in a local history to further send these to the server side in bunch during specific window and so on. So on the in the server side, we have implementation using .NET Core with C# as well, and SQL Server relational database, and the time series reading and processing for this case, for this solution I am presenting, was coded both in R and in Python. The feature engineering, model training, and other this stuff was performed using R and Python as well. I first created using Python, and I applied the support vector machine and other algorithms. And after that, I turned this code into Python code. But more specifically, and it is relevant to say that the agent and each agent will need to be coded using a specific thread, that because the agent is autonomous, because we have predefined capabilities and functionalities running on a thread, and this thread can communicate with another agent that is another thread, and this communication can be done using in-memory in-memory message broker, or a distributed with persistent message broker as well. with no problem. And the ontology we implemented in OWL format and RDF, that is a text-based format and is totally capable of being read from a machine. These are three screens from the smartphone, from the mobile application. For example, on the left side, we have the semantic location, because once the application identifies the user is spending some time on a specific location, that smartphone application can ask to the user to label that location. So the application will then save these and correlate with the latitude and longitude. So we have a specific location that is meaningful for that individual. And this is important to provide insight with meaningful location for this case, for this model. So in the right side of this picture, we have a stress level assessment, because we can ask to the individual to register what the user is feeling at that specific moment. These some kind of questionnaire has limitation, has pros and cons, but this is a way we can, for example, label our context. So being very specific to the characteristics, being specific for in the feature that this model extract from the RR intervals using a short-term time period comprised by 5 minutes. We have, for example, these time domain and frequency domain features. This time domain is the time domain feature was computed using a time series, and we have, for example, simple statistical calculation, such as the average of the NN interval, that is the normalized form of the RR interval, and so on. For the frequency domain, we need to apply some preprocessing aspect that I talked about in the agent capabilities. That is the interpolation of the heartbeat and the application of the fast Fourier transform to have the frequency compute to create that frequency from the raw data. So we have, of course, the label on these data that in my case was stressed and not stressed. What's more, so the idea of the implementation is to take the raw data that is characterized by the techogram in the left bottom side of this image. So we can read the raw data and apply the pre-processing, the feature extraction, and then run inferences according to our previously training model. But that model can be training for stress, and a very good research was done in and is presented in the literature on stress recognition. And we have other articles that describe the anxiety as well. And the idea is to compute from that raw data characterized from the techogram, compute, retrieve context, process that context, combine information, and generate insight for the psychotherapist, for example. So we have in the right side a bar chart that describe a time spent in some specific location, and in blue what this how long of this time the user spent in a possible stressful situation. So that's the idea to bring insights from the daily routine to the psychotherapist. So some challenges I judge all these stuff and this topic consider, and of course this challenge will lead to opportunities, research opportunities. For example, pattern identification of physiological measurements can be a challenge, and identify how different arousal manifest in data measurements, and as well as identification of patterns from the psychological measurements. Why not? And how we can correlate the physiological with the psychological. Moreover, we have the subjectivity of the psychological state. This is a challenge because stress differ from one person to another, and this is very challenging. And regarding more related to the computing, the abstract and generic model of context, but of course, for the previous item regarding subjectivity of psychological state, how we can create a software model that can derive, or that can specify some kind of subjectivity to eliminate it. This is very challenging and a very hard to solve. And of course, the privacy of the individual during daily situation, because with this kind of solution, we are reading information from user, and the privacy is very, very relevant in this topic. And of course, the security of this information, once we read this information, how we manipulate, how we manage this information, how we persist this, how we process, who is the in addition to who is the owner of the information, maybe the user, maybe the researcher, maybe, I don't know, maybe the working environment. So all these things should be considered during solutions on this topic. Some references that describe the presentation, and that is all. I would like to thank Professor Ivan, to thank the Open Dais project, and I'm proud to be part of this project. Thank you, Ivan. Now I'm open to questions. Feel free to ask whatever you judge relevant.
Okay, thank you so much, Rodrigo. It was really a very interesting talk. So thank you for providing this information. So actually, it looks like the model which you are presenting here about the building this data and everything, it's can be actually used together with the. So there are different models explaining some, for example, different psychological models and so on. So your platform can be used, for example, for data gathering in many aspects, and different models can be used actually to analyze and process gathered content information, right? So this
Yeah,
can be
right, right.
extended.
Yeah, of course, of course. That's because the ontology I previously mentioned is abstract enough to specify information, considering what the researcher, the developer judge as relevant to process, and we can have a model maybe to describe things related to the information retrieved from daily, or we can have, for example, a model that describe derived information in a high level, and we can of course use a machine learning model to derive this information, right?
Yeah, thank you so much. So I don't see any questions, so so there is a in the chat congratulations from the Professor Barbosa, so on your presentation. So
Thank you, Professor Barbosa. Thank you.
Okay, so while so we don't have any yeah, thank you, Professor Barbosa. So while we don't have any questions in the chat or question answer session, so I encourage everybody who joined actually to post the questions if you have any. So don't hesitate to do this. So just maybe related to psychology, but not related to your particular presentation. So I was a couple of days ago reading some article about actually different stresses and so on. So what you was talking initially, so that's the problem. And there is a point that's pretty much right now we have so many psychological problems among the people, and that is caused by that we are living in too comfortable environment. So we don't have any real stresses. So that is why even small actually fluctuations in our schedule, or even small things which were maybe years ago even not noticed, right now can cause a depression and so on. So do you have any thoughts on this? So what do you think about this position?
I think we have very different situation that user can face it, and this situation can, for example, trigger mental issues, but these situations can also provide some mood aspect of that user that is not very related to an issue, but we nowadays live the whole situation that our mood can be unstable. So I think it's hard to differentiate between, for example, a physiological arousal from a mood, happy, sad, anxious related to the mood, but not related to an disorder itself. So we have a gap between chronic issues and how can I say, specific issues of that moment. So I think it's hard to differentiate from one and another. So the people can suffer for a simple mood change, but it does not represent that the specific individual is suffering from a mental disorder. We need to follow the individual and try to to understand better the whole context around that individual.
I see. Okay. Thank you so much. So I don't see still any questions. So I think that means that it's very well prepared talk, and it's very self-explanatory. So it was clear for everybody. So we have a good participation today. So 45 people were listening to you. So some more congratulations are coming in the chat from Elder Aruda. So thank you so much for your comments. Video will be available shortly on the YouTube and our web portal, maybe closer to the end of this week, because my main laptop have some issues. The cooler of fan died in it, so it's pretty quickly overheats, so I can't edit video on it. So, but I'll prepare and publish everything shortly, hopefully till the end of this week. So if we still have any questions or comments, I just want to say thank you to Rodrigo. It was a very good presentation. I really enjoyed it. And personally, I learned a lot of interesting things which I was not aware about. So thank you so much.
Welcome, Ivan.
Okay, so have a nice day. Thank you so much.
Thank you once again. Have a nice day. See you.
See you. Bye.